All right, team. Let's do another one of these. This will be a lecture on cloud computing for ELT218, Intro to Networking. The quiz will be up next week. Might actually make it accessible early in case you guys want to get a jump on it. But let's go get started here. Okay. So we're going to talk about cloud computing. Recording on. Okay, good. And a little bit about remote access too. So what we want to do is think about the features of cloud computing, why it exists, why it's a thing. Explain remotely connecting to a network. We'll discuss some of the mechanics that go along with that, like VPNs and methods of encryption. We're also going to talk about user authentication, and it's going to be a lot of security talk, frankly. The whole idea of cloud computing is to store all of your valuable assets in a central location that's accessible from everywhere. So it's on demand, so you can add to it, shrink it at will. It's scalable. So it supports multiple platforms and everybody in multiple locations. Resource pooling and consolidation's also part of it. And then you also can kind of charge for it piece by piece. And what it looks like is sort of this. And we've talked about all these things in class, about having database servers and network servers, storage servers, identification platforms, stuff like that. And in the cloud, you're moving it all to a network location that might not be on the same campus as you. So Johnny Logan has some things in Microsoft's cloud, for example. Your email and your Outlook calendar, things like that, are stored with Microsoft's cloud. But then your grades and your other stuff with Jezebel or whatever are stored with Johnny Logan's cloud. And you can access all these things with tablets, laptops, phones. It doesn't matter. It's totally accessible from everywhere. Another concept we want to get into this time is virtual desktops, such as thin clients. What you're looking at here in this picture is the back of a Dell monitor, and this little box bolted onto it is the entirety of the computer. It doesn't have a hard drive per se, doesn't need one. It just connects to the monitor, the keyboard, the mouse, and the network. And whenever you turn it on, you press the power button, it actually boots up a very thin version of an operating system, connects to the network, downloads Windows or whatever you're running your network on, and boots over the network. Then you have network applications, you have Microsoft Office on there, you could have SPSS on there, you could have Photoshop, whatever. So you store everything on the server. And that's called thin client. Doesn't necessarily have a fan, so it uses less electricity. No hard drive, so there's nothing to fail. All the data is automatically stored in the cloud. No OS, so you update the OS on the server and all the clients are automatically updated. Same with the apps. Central location means you do the job once and then it's copied out to every one of the thin clients. Here's another example of one. You can see this little box has USB, it has microphone in, headphones. It's a complete computer, VGA out. There's a DP out for your other monitor, for a newer monitor, and Ethernet. This has everything you need. It's a complete computer, but no hard drive. There's a closer look at all that stuff. So the book focuses a lot on this, the different models of cloud computing, such as infrastructure as service. That means providing hardware network services, like the cloud is your network server, your Active Directory, your logins and passwords. Your platform as a service is where it's delivering operating systems or environments. That's where it's like handing out a Linux that your thin clients boot from, or Windows. Software as a service is handing out, it's like Microsoft Office Online, think like Google Docs, stuff like that. And then XaaS, anything, is sort of their catch-all that they use when they don't know what else to say. And there's another look at those categories. You can see infrastructure as a service is your server, storage, network. Platform is your OS, and then think Google Docs again for software as a service. Here's some other examples. Amazon provides infrastructure services. So does Microsoft. They call it Azure. And then software as a service, there's the G Suite right there. There's Office 365, and some other choices. Another interesting question, just for sort of theory craft for us, is an MMO video game a cloud application? To answer that question, we have to think about what does it store in the cloud and what does it store on the local computer. It's not infrastructure. It's not providing the operating system. And you could say it's providing the software, but not really. You have to download the WoW client and install it, like wow.exe sits on your local hard drive. You cannot run it from the cloud. So it's not a conventional cloud as far as infrastructure or platform or software as a service. So not really. Even though it's required to be online to play, it's not really a cloud game. Now, public cloud, again, Google Docs, prime example, provided over the public internet. You can log into Google Docs from anywhere. Any internet connection gets you access to it, and it's free. Basically a walking, talking advert for Google Docs. It's great. Private cloud, this would be on your organization's own servers. This is like your student information system at John A. and SIU. They're only accessible when you're on campus or if you VPN in from off campus. That's a private cloud. Now, community cloud would be if there was a server that you could access from either John A. or SIU's campus, but nowhere else. That would be a community cloud shared between those two schools. And the hybrid's anything in between that doesn't really fit those classifications. So remote access allows you to connect to a remote server, LAN, or WAN, different location. Okay, that's pretty intuitive, right? Point-to-point over dedicated line. Virtual private network goes a step further. Rather than just server client into this other thing, it's as if you're there. You log into a VPN, John A. Logan's VPN or SIU's VPN. It is as if your computer is now on campus. You can access anything that you could access on campus. And anything that you couldn't access from there is now also blocked because you're essentially relocating in a theoretical sense. So it's a little trippy, but you get used to it. Remote terminal emulation is for big nerds. When you just want to do command lines on the server, like, oh, I just want to tell the server to reboot, or I want to tell this to shut down, or that service to start up, you just remote in and type terminal commands. So you're very comfortable with that. You don't need an interface, mouse, keyboard. You don't need full remote desktop. You just terminal in. So if you got enough people doing this at your organization, you want to devote a whole server to it. So it's fast, so it's responsive. So when they click it, it fires right up. So you set aside this device. You buy a big old Cisco AS5800, and you set it aside and go, all this computer does is let people VPN in through it. So it's devoting all of its processing power and network bandwidth to just that. It's not a print server. It's not a file server. It's not sharing anything else. That's all it does. This facilitates a better experience for your remote users because, as anyone will tell you, I just talked to someone recently this week, and due to the quarantine, they're having to work from home. And their company gave them a bootable flash drive that essentially VPNs them in or remotes them into work, and it's so slow. Every window they open takes 3 seconds to open. Every program they run takes 20 seconds to launch. It's almost unusably slow. Their IT department has done their colleagues a disservice in building it this way. And they're going to have to improve it. That's like, there's no way that's going to fly for the duration of the quarantine for it to be that crappy. So you want it to work well, but you also need it to be secure. Part of what a VPN does is provide security. You got to log in and put in a password to get on it. And it should be an encrypted connection. So anyone who happens to spy on your data or tries to get access to whatever information you're passing back and forth just gets a bunch of gobbledygook because it's encrypted. They get gibberish. Okay? That's the whole purpose of it. I'm very proud of this line. I'm just going to let it complete. There we go. Very nice. So this is a good map of how VPN works. You're this remote user. You're this guy over here who's at home and needs access to all these resources at work, either through your home office or through your little tablet or whatever. You log into the VPN tunnel. That gets you through your workplace firewall, access to the work router, and then it's as if you're on the network. It's as if you're here, even though physically you're still over here. That's the idea. And here's the login screen from ours at SIU, just as an example. So these are going to make you appear as if you're somewhere else. Another weird use for a VPN I've seen is people who want to watch a online sporting event, but they're in the wrong market or whatever, and it's blacked out in their area. You can VPN and pretend to be in the right market, and then try to pull up the stream, and sometimes that will work to bypass the protection. It's also technically illegal. They could complain at you. I don't know what they could do to you for doing that, but that's one use of a VPN, is to appear as if you're in a different area than you really are. So they can carry whatever data you want. When you log into a VPN, typically it takes over your entire internet connection, and everything you do while you're logged into it then passes through that VPN normally. So you sign into John A. Logan's VPN, and your Facebook traffic now goes through that tunnel, and your video games go through that, and your Windows updates are now downloading through John A.'s internet connection. Everything passes through it. That's a client-to-site VPN. Site-to-site, let's look at that. Site-to-site is when you work for a company and they're like, hey, bro, we have 4 different buildings in Detroit, Charleston, Los Angeles, and Seattle, and we really want them all to see the same database and the same file storage and even print to the same printers and just kind of output. They want them all to behave as if they're one building. So you say, okay, you VPN the entire network, site to site. The central office, the branch office, all of these other places look like they're one place when you are on the network. So you can access the Charleston branch office's files from the central office. No problem. That's what site-to-site VPN does for you. And then you have the clients hop into that VPN, and they're connected to all those other locations too. So this is how companies organize their networks if they're smart. Right now, across the country, across the world, there is a giant rush of companies who never before thought about doing this sort of thing. 2 weeks ago, they told you your job could not possibly be done as a work-from-home job. Now every job in the world is technically a partially work-from-home job, and we're discovering that a lot of them can be done that way. Most of the studies done so far show that people work from home pretty efficiently, even a little better than they do from work. There's no commute, there's less stress, they're more relaxed, they get more done. So it's not going to be a downside for anybody, really. It's just a huge adjustment for a lot of places and a lot of jobs. And then you really need to think about the people who can't possibly work from home, who still have to go to work. Your medical people, your cashiers at the grocery store, your delivery people, they still have to go to work every day, physical jobs, stuff like that. No choice for them. But if you can work from home, now's the time to seize the day and learn to do it through your work and make sure they do it right. So, yeah, this one's kind of redundant. We'll skip that guy. So, there's a lot of different options on VPNs. And they use a couple different encryption schemes. We're not going to go too detailed on them. But they do IPSEC, SSL. And remember that VPNs operate at the data layer. They encapsulate at that layer. And a couple of VPN tunneling protocols are PPTP and L2TP. One being the older one that we don't use much anymore. No longer considered secure. We've got a new one called L2TP, and newer is better. Again, we invent a thing, we iterate on it, we improve it. So the better encryption, the better security. That's what you want to go with. Okay, terminal emulation looks a little bit like this. You telnet in, and it's as if you're sitting at that computer with a command prompt open. You can run whatever command lines you could run as if you were physically there. You have whatever admin powers and permissions you do or do not have as if you're there. And then for a graphical user interface, there's a million options for this. I have a video later I'll have you guys watch that I'm going to link in the comments below that gives you a great example of how remote desktop works in nefarious ways. But with the GUI, if you remote control into yourself, you get a screen like this, just infinite screens within screens. There's not really much educational value to that. It's just cool. Okay, encryption. Don't be afraid. We're going to stay pretty simple with this. And anybody who truly understands the math behind this will be ashamed at the way I'm going to explain this, probably. So, Let's go back to World War II. The Germans and Japanese are communicating with radio, but they're not saying hi, how are you, or guten tag, or ohayo gozaimasu. They're encrypting their communications with an early form of encryption. So you listen to what they're saying and it doesn't make any sense. It's all gibberish. It's encrypted. Well, the Allies put together teams of nerds to try and crack the enemy encryption. One of the most important people on one of these teams was a guy named Alan Turing. He's born around the time of World War I. He's a student at Cambridge, but some say he's like the father of modern computing. The ideas that he put forth to try and counteract German encryption became the building blocks that we use to build modern computers on. Okay? And he built these machines that did nothing but get wrong answers. Okay? So when the Germans made a code, there were, say, 20,000 ways to try and decrypt it, and one of them was correct. Or 5 or 6 of them were almost correct. And so what his machine did is verify that he had the wrong answer. And so it was like this gigantic math problem that the machine would work through, and he would come up with hundreds or thousands of wrong answers every day, and that brought him closer and closer to getting the right answer. And this caused a lot of other theory craft to happen. They started thinking about, what if we made a computer that was so smart it could actually think and make little decisions? And that's when Turing came up with the Turing test. A computer would deserve to be called intelligent if it could trick a human into thinking that the computer was human. That's pretty much what a CAPTCHA test is. When you run a website like Facebook, you don't want people scripting bots to log into it and spam everybody. So you put a CAPTCHA test on your login. So a human being has to visually identify something or figure out something based on context that your typical spammer script or bot could not possibly understand. So this weeds out the bots and the humans. Now, unfortunately, some bad stuff happened to Turing after the war. He helped the Allies win the war by cracking the German code. And we publicly humiliated and tortured him for being gay. He eventually killed himself, and it was basically due to societal pressure and torment. If we hadn't done that, he might have lived another 50 years and invented who knows what. But out of his work and others during World War II, we get the concept of a cipher, which is a code, takes a legitimate message, scrambles it into encryption, keeps information private. In encryption, we call this a key. It's either called a cipher or a key. So this allows you to send a message from person A to person B, and they each have the cipher. And if you don't have the cipher, you can't read the message. If you do have the cipher, you do have the message. That's encryption, okay? Looks kind of like this. We encrypt the text into gibberish, and you decrypt it back into actual letters. That's symmetric encryption. We each have a copy of the same key, and we can each unlock it. So there's a lot of little programs you can use where you can put in actual text and encrypt it and decrypt it just to play with this. Scramble your text into a gibberish block. And what Turing and the others did during World War II was essentially a brute force attack. We're going to try 20,000 different ciphers, and eventually we're going to get lucky and land on the one that unlocks the code. That's how they cracked encryption, because the encryption was simpler then, and even a simple machine could eventually brute force the right answer. It's tougher now. Encryption's a lot more sophisticated, and it's harder to just break in. So a single key is known by the sender and the receiver, and the same key is used on both ends. But how do we do that? We start with this message. First thing we do is we go, hey bud, I'm going to send you a message. I'm the sender, and first thing I give you is the private key. I'm like, okay, you got the key? You got the key? Cool. Now I'm going to send you messages over the next month or 6 months or year, and they're all going to be encrypted, and you're going to unlock all of them with this key that I gave you earlier. That's how we're going to communicate for the foreseeable future. And every so often, it would probably be smart if we got a new key, right? Keep changing it up. So public key encryption is a little different. It uses two different keys. One key is only used to lock the data, so it scrambles it. The other key is only used to unlock. Okay? And this is called a key pair. You need both keys to do this. One to lock it, one to unlock it. Okay? Again, just barely scratching the surface of how this works. But it's still required that the recipient has the unlock key and the sender has the locking key. Okay? And this is how we do a lot of things on the internet. This is how websites and other servers have a certificate that verifies that they're them. And it's encrypted and secure and verifies with another organization called the Certificate Authority. This is why when you go to apple.com, you don't get any warnings like you're in a weird website. And when you go to, applescam.com or whatever other goofed up website, you might get a warning from your browser going, you're in a weird place. Do you really want to be here? That's one of the things we do. Another thing we do, if you work for John A. or SIU, you might have to do this, is get a digital ID with your driver's license from the state of Illinois. It's kind of a process, but once you get it, you get a login and password, and you can digitally sign documents like PDFs, and it counts as your legal signature. And it's verified through state of Illinois with your PKI. So, pretty cool. IPSEC stands for Internet Protocol Security. This is one of the older methods we use to facilitate this. And you regularly have to reestablish. Remember I said you might swap a key with someone and then use it for a month? You regularly have to redo these things. You can't just say, this is our key and we're going to use this for the next 10 years. If the bad people find it a few months in, then they're just listening to everything you do. Even during World War II, the Germans changed up keys all the time. The Axis did. And we had to keep cracking their codes. It wasn't good enough that we cracked it once. We had to keep doing it. SSL, Secure Socket, also uses TLS. This is a little more modern protocol. It's a combination of protocols that work together. That's basically all you need to know at this point for this next quiz. You need to understand that they have a handshake protocol, sort of like TCP handshake. Hi, I'm going to send you a thing. Okay, I'm ready to receive the thing. Okay, here's the thing. It's sort of a conversation that happens over and over and over again. Let's see. And this little guy is a device that just does nothing but SSL VPN connections. This is like we talked about earlier, a VPN server, VPN concentrator. You put this device on your network and people log into it, and it lets them in. Okay. Smidgen on Secure Shell. Yeah, I don't think we need to focus on that much yet. You just need to know that SSH is a secure, like we talked about, a remote command line. It also can facilitate other traffic. SSH has to be on both machines, but this is now a protocol that's built into all major operating systems. They can all do it. You do a client and a password, and remember that SSH lives on port 22. Okay. You might have heard of FTP. It's like a file server. You can download files. Well, SFTP is just a secure version. It uses SSH. So it's a combination of these protocols. We have FTP to move files from one place to another. We have SSH to secure it, to lock it down. And SFTP lives on SSH's port of 22. Okay? Combining our protocols, kind of building a whole structure here. Okay. Of course, you know what authentication is. That's proving that someone is who they say they are. Usually a login and password. Could be biometric. Could be other ways to do it. We've had a number of protocols. Again, remember, we create a thing, we iterate, and we improve it. We originally created PAP, Password Authentication Protocol. This was like an early cop of authentication. But it sent the login and password in clear text. So if you were the sort of person who was able to pick up random packets on a network and listen to them, you would see people's username and password fly by. Not secure enough. We needed a more modern cop to protect us. So we got CHAP and MS-CHAP. We still use this for jumping on the Wi-Fi. At John A. and SIU, you jump on the Wi-Fi. Your phone will, at SIU, if it's an iPhone, it automatically detects that you're going to use MS-CHAP. You're going to use this more complicated password scheme to secure and get on the VPN. And Johnny does the same thing. For some reason, we have it set up, and we have a weird problem at SIU where Android devices don't automatically detect that we're on CHAP. So you have to tell it, hey, use CHAP. Just a weird little tidbit. So the way this works is it issues a challenge. Here's the challenge plus my encrypted password. And here's acceptance or denial. That's a CHAP handshake. Considerably less friendly than, hi, I want to send you a thing. Hi, I'd like to receive the thing. No, in this case, it's, who the hell are you? No, you're not coming in here. It's like a bouncer. Okay? CHAP version 2, stronger encryption. Again, iterating on the same idea. Once you authenticate that you're you, it would be kind of handy if that authentication would give you access to everything you're supposed to have access to. That's where single sign-on comes in. So you go to a computer lab, you sit down and you log in with your student ID and your password, and that gets you onto the computer, verifies that you are you, and then you open up your email, it's already logged in. That's single sign-on. It's like, okay, Bob has logged in, I'm going to log into Bob's email, Bob's calendar, Bob's database, whatever. It saves time, and it doesn't decrease security because you still had to log in that first time. And the more secure you make that first login, the better off all the subsequent logins are. So that first login, you might use two-factor where code gets texted to your phone, or you have to fingerprint, or you have to do a combination of things. Multi-factor authentication is a thing. And with everybody going online for everything now, you can bet that more and more places are going to demand two-factor authentication. It's going to be a thing that you have to live with. Everybody. Sorry. It's not that bad, though. So, you might authenticate with someone's knowledge, like what's the password, or what's the first school you went to, or what's your mother's maiden name. Might be possession, something you have to swipe a card, you have to put in a key, you have to plug in a USB dongle or drive, or inheritance, something you just have, like your fingerprint, your retinal scan, your voice recognition. Okay, multi-factor requires more than one. It's more secure that way, though. Now, passwords have been a hot topic for a long time. Back when we used to rely only on passwords, we had a big debate at SIU, and I think John A. probably did too, about how are we going to do this? A short password that's got a bunch of complicated characters in it, or a longer password? Well, longer passwords are tougher to brute force. It is easier to brute force the word potato than it is the phrase desperate house cats, because there's more characters you have to guess. Every one of these characters is another thing you have to guess about the cipher. The more often you change the password, the more secure it is. But these days, I think information security is moving more towards, let's do multi-factor. Let's text your phone a code. Let's make you also fingerprint. Let's do multi-factor and let people have less terrible passwords to remember, easier to remember, and that don't reset every 60 days. Like we reset every year, but we really need to go to two-factor. Okay. So, a bit on misconfigurations. People will mistype their usernames and passwords all the time. I once was talking to someone who worked at SIU phone support for a long time, and I said, how many cases do you close in a day? And they said you could close 70 to 80 cases in a day, but 80% of them are people who lost their passwords or locked their account from failed password attempts. So it's super common. It's a real problem. You could have an old device, like an old laptop or an old phone that can't do WPA2 encryption, so it can't get on your Wi-Fi. You could mess up your user account activation. That actually happens a lot with the state of Illinois signatures. Incorrectly assigned ports. Yeah, there's a lot of ways for this to fail. There's a lot of moving parts to this at this point, so plenty of places where it could break down. Some of the things you want to check when you're just inexplicably unable to connect to a thing, make sure you have the right date and time. A lot of these encryption protocols and other things make sure that you're on the same page about what day it is in time here on Earth. Make sure you have permissions to do what you're doing. Make sure your account's properly activated. If it fails at any point, the state signature thing, you just have to call them and say, I failed to set up my signature. Could you please unclog the logjam here? And then you can also just make sure your internet's working with your good old command line tools such as ping and tracer. Okay, you guys are ready to take the quiz on cloud computing and VPN and encryption. It's not too bad of a quiz. The lab we were going to do, and we got to do in Section 2, and Section 1 you're not going to get to do it, is about remote access. We were going to remote control various computers in the room and do just minorly dastardly things, type nasty notes to each other in each other's notepads and stuff like that. But can't do that. So what I think you should do is watch a video on YouTube where remote desktop is intensely used. And one of the most amusing and entertaining and relevant to this course is scammers, such as Kit Boga and the other guys that do this. There's a huge surge right now in cyber attacks and scams where they call you, they tell you, oh, your computer's got a problem. We've detected that you have a virus, or blah, blah, blah. We're from Microsoft and you owe us $200. And they ask for control of your computer. Once they have it, they try to get your passwords, they try to get access to your bank account, they try to get anything they can on you. And the scammers scam them back. They pretend to be a mark, a victim, with a fake computer using a virtual machine. And so they let these criminals remote control their virtual computer and let them think that they're stealing real information, and in fact it's all bogus. So I'm going to put the link in the comments below, and I highly recommend you check it out. It's very entertaining and very educational for anyone. And that's pretty much it for this lecture. Thanks very much, and see you next time.